Thank you very much for having us here. First, I have to install my backup. Uh, for everything, it's the first time, and we need 2 minutes.
Fill 2 minutes.
Fill 2 minutes. For everything is the first time, and this is my first English presentation. So I hope you have patience when I search for words. And I have a little backup on my laptop, and I have Sophie with me. Are the 2 minutes full? No. No, sorry. Let's tell a joke. Two researchers at a congress in Barcelona.
Maybe just start by introducing ourselves. We can fill some time.
Oh yeah. Before the first sheet appears, I can introduce who we are. My name is William Mensen. I'm a lecturer and researcher at the Hanze University of Applied Sciences in Groningen, the Netherlands. And I'm here together with my fellow researcher and colleague Sophie de Klerk. We're working for the research group Digital Transformation, led by Professor Rick Groenboom. And our presentation is about a collaborative pilot implementation in radiotherapy. And we had some similar experiences as Lars just told. There was a lack of information. This is what a presentation is about, and another part of the presentation is led by Sophie, and is about a technical implementation. Even kijken. Oh, thank you. What's my background? My background, I'm a technologist. My background, I worked 12 years on radiology and nuclear medicine. And with that experience, I work on the project on radiotherapy. And what's your background? Maybe you can tell it yourself.
Yeah, I'm a human movement scientist by trade, but I pivoted more towards IT, so I'm connected to the IT program at Hanze University of Applied Sciences. So I've William mainly with expertise in clinical modeling, and then I'm connected to the IT program. So our presentation will also be in 2 parts. He's going to tell you about the clinical modeling aspect, and I'll tell you a little bit about the pilot implementation that we had. We still don't have a presentation.
We just needed to change the setting, but we've got it now.
Okay, we're getting there. I think we're gonna have to speed up our presentation a little bit to facilitate the rest of the presentations.
Now we're on this side. I'm on this side. I have to introduce our fellow researchers who are not here. We work together with Juri Lipman, is a radiation oncologist on the Isela Hospital in Zwolle, and together with Rogier Jansen. It's a physician. They work together with us, and we get supported by students from the Hanze and technicians in practice. Normally at this point I have to introduce openEHR, but I think you know all of them. You know what openEHR is, so I'll tell a little bit of radiotherapy. Radiotherapy is a treatment of tumors by radiation. The radiation can get on similar modalities, different modalities, called the LINAC, the cyber knife, gamma knife, and every modality has its own technique. And that's the difference, the difficulty in our job. There is an archetype, but there are a lot of modalities and techniques. Am I right? Yes, thank you. There's also different software. Excuse me, I need a little bit. In the Netherlands, it's quite common to work with multiple software applications, and at Isla Hospital, the radiation oncology department, there are three main systems used. HICS, and HICS is a Dutch company, as electronic healthcare record, and together with Epic, it's it dominates the Dutch market. The second one is RayStation. RayStation is a Swedish application and is meant for radiation planning. In the upper viewport, and this is my background. In the upper viewport, you can see a CT slice with a tumor marked in green, yellow, and red, and the blue indicates the radiation beam. Normally, images are stored in DICOM, but there is a clear need for clinical information. And the third program is Mosaic. And Mosaic is the oncology information system used for the workflow and controlling the modalities. Now I have to pull up the slide. As mentioned, there are multiple systems, and each generating its own data. And the radiation oncology department at Isla expressed a clear need. They want to manage and integrate these diverse data sources for research and business intelligence purposes. And this is where openEHR comes into play. Because it has emerged a promising solution, and it's offering a semantic consistency through archetype-based modeling and increased interoperability with standards like OMAP and FHIR. I think that's well-known information for you, but it brings us to the objective of our project. It was to evaluate the use of openEHR as a persistent solution for radiotherapy with a focus on secondary data use. What we like to do is explore both technical and clinical aspects. So we conducted a collaborative pilot implementation at Isla. Sophie is about the technical implementation, and my expertise is modeling. For the clinical aspects, we began modeling with the irradiation archetype. It was firstly developed by the HIMED consortium in Germany, and the archetype is designed to be used in the procedure slot, and in the procedure detail slot. And in the CKM, it's currently drafted, but it is drafted for a couple of years. And as Lars mentioned, what do we know? Sorry, I pick up my text here. In practice, the radiation oncology department in Zwolle requires more detailed information than what currently was described. For instance, techniques like integrated or sequential boots during treatment trajectories are not adequately captured. Additionally, important parameters such as beam energy are missing, and some header labels also lack clarity or consistency. For example, the distinction between treatment methods and application type is unclear. through our evaluation, we realized that there's still no universally accepted common language in radiotherapy, which complicates efforts in research and business intelligence. As a result, our clinical modeling evolved into a development of a common data model. I understand you can't read this, but if you want to know more about the details, I would like to invite you to get in contact with us so we can discuss about the details. But I can tell you about the common data model, and it's it's a comprehensive list. We think it's a comprehensive list, and it's recommended by Denstad. Denstad is a professor and of a researcher, and he found there is a lack of a comprehensive list, and at the same and openEHR at the same time encourages maximum data sets. Even kijken. Sorry, ga ik in Dutch. Yeah, but we would like to make a comprehensive list, and sorry, ik ben het helemaal kwijt. Kun jij het heel even overnemen? I'm sorry, I lost my story, and Sophie told for.
Okay, I'll try to take over for the clinical part as well. So what we set out to do is try to see how can we find all of the data elements that we need for radiotherapy. And there are some different guidelines by the American Radiotherapy Association and the European one. There are also some scientific articles, but they mainly focus on minimum data sets. Then we have the people in the hospital, so we have a radiation oncologist, we have nuclear physicists, etc., all working together on sort of getting all the elements that we needed. Together with them, we got to this common data model. And that's sort of the point where we're at now. What we do need to do is have broader validation and get a broader consensus. And I'll tell you a little bit more about that later. But I'll try to speed up the story a little bit, because I'm also aware that this is a clinical session, but I do also want to talk a little bit about the infrastructure. So what we did at ISALA is that we also wanted to show that we could actually have this infrastructure for them. So this is specifically for research and secondary data use. So we're not touching the primary process, we're really looking at data analysis. What we did, and that's actually really nice at ISALA, is that radiotherapists have a lot of freedom in the hospital. They're very technical people, they're very IT-minded, they have their own physicists and IT people. So we had a little bit of freedom in their IT environment, even though we didn't really have an official project going on with a project budget and everything. We had some freedom there. So I was allowed to give them a Docker Compose file and let me put up some infrastructure inside the hospital. We took Airbase as an open source implementation of the openEHR standard as sort of the cornerstone as our openEHR server. We have Keycloak for access management. We have Snowstorm, which is a terminology server, also open source for SNOMED CT. And then we couldn't really work with something like Azure Functions or something similar. So we had a Jupyter Lab server where we could just run scripts. And that was also something that they already had in their existing infrastructure. So that's something that we could sort of use as a starting point. But of course, you would need to run this periodically. So what we did is we took the data from Mosaic, mainly, got it through a SQL query, and that's also what the data analysts and BI specialists at ISALA do right now. The thing is, you need to understand the entire internal data model and also understanding what tables you need to search. So working with openEHR is a lot more friendly because you're getting archetype-based queries. But we had a huge SQL query to extract all the data. We did the mapping to flat JSON. And we also did some mapping between ICD-10 and SNOMED just to get everything in the format that we actually want it, we also use the Snowstorm server for that, because you can also use it to generate the mappings for you. We ran this all through JupyterLab, but again, this is something that in the end you would need to set up in a slightly different way. So, in the end, what are our main findings? Well, what we found is that there's a very nice sort of foundation provided by the HIMET consortium, but yeah, it's still in the draft form, and it's very similar to the previous story, where it's like, yeah, no one's sort of adopting it, and then yeah, it's just sort of hangs there and stays there. What we also found is that there is this clear need for a common data model, a data foundation, because yeah, it's just not there yet. And we have it with the imaging, but not with the clinical aspect of radiotherapy. And then we also have this sort of proof of concept infrastructure that actually works very nicely for this. And it's very lightweight, but it does allow you to actually yeah, run these types of tests and prove that it actually works. Okay. So our next steps, and that's also really important, we need to validate this model further, and we have a consortium in the Netherlands of all radiotherapy departments. So that's very nice, and that's going to be the next step for us. There's basically two applications. So there's a duopoly in the radiotherapy market, just like in our electronic health record market. But what we see is that there's also a lot of freedom within those applications. So there's a lot of differences between centers and how they do stuff and how they have set up their environment. So we do need to involve this consortium and also see what their needs are, and maybe yeah, refine the model a little bit. What we also really wanted to do for the BI specialists is that right now they can use AQL queries, which is very nice. It's already a big upgrade from directly using SQL on all the different databases. But we also want them to be able to work with OMAP, so that's also going to be a next step. And then, of course, we need to improve this infrastructure, because you can't just keep running everything from JupyterLab. At some point, you need to actually have proper infrastructure, so that's also going to be a next step within ISALA. Yeah, so one short thing I do want to mention is that I'm looking for William to continue his work in clinical modeling, so we're setting up a PhD project for William to do just that. My PhD is in wheelchair biomechanics, so if you're interested in that, hit me up. But we are continuing this work with ISALA, and we hope to also contribute back to the CKM in the future.